Okay, so now we're going to take a look at hypothesis testing and how can we use it to understand, again, X variables. So we're thinking all this kind of toolbox of statistical things, and we're going to use to solve problems, use to connect X's to Y's, right? The practical way. So hypothesis testing, I can test two different things. We're going to test if a certain value could be the mean of a sample or a distribution or not, or you can test if two samples can be the same mean or not, or they're not with the same mean. Okay, we're going to learn about these two. It's called one sample t-test and two sample t-test, right? So remember that we have a population of stuff and we're collecting a sample or two samples of that population. Let's say how many sandwiches we're producing. We're collecting a few of them, and then we're testing if a value could be the mean of the population, or if those two samples come from actually two different populations or the same population, right? So hopefully that was less confusing. And we're going to do some F tests as well, but basically these are the first two hypothesis testing. So we create, confidence intervals and look at that. So we're going to determine if a value is a cause for alarm or not, if that value could be within the range of the mean or not, and the two sets, and also that what I just explained. So some assumptions that there's independence between the samples. So the samples that I took randomly, taking them from different moments in time, or if I do like more structured data collection, which we learned in the past. Normally distributed data, and I can be unknown variance or known variance. We're going to take a look at that. So first thing we need to do is formulate the hypothesis, what I'm going to testing, what will be the null hypothesis, which is this HO here, and what will be the alternative hypothesis, which is the HA. We need to determine the level of significance, and with the level of significance that will determine actually my p-value, right? So hypothesis testing, if you guys remember from your stats class, is all about p-value, right? Look at the p-value. So usually we're going to use a 95 confidence, which will give us a p-value of 0.05 or low to be considered, right? And we're going to collect data, test, and then we're going to apply our statistics and draw some conclusions here, right? So first thing, formulate the hypothesis. And I know that a lot of people have doubts and questions how to do that, right? So the way that I do that seems practical and works, is always formulate the null hypothesis as the most dumb and not excited thing ever happened, right? So the null hypothesis is you don't have anything in the end of this testing. So imagine that we're going to test two different samples, right? So the null hypothesis is they're not different, they're the same. So you didn't find out nothing, right? So that's usually our null. Our null is usually they are the same. There's nothing different between them. And then the alternative hypothesis is, oh, they are not the same. So something interesting is happening. And that's the alternative hypothesis. So the alternative could be, oh, they are actually higher than each other. Or A is higher than B. Or B is higher than C. Or B is lower than A. So whatever that is, or different than, whatever that is, it's something interesting, right? It's something, wow, that's cool to know. So that's the alternative. So null is the dumb, right? And the alternative is the fun one. Yeah, you can say that. If you have fun with stats, which I do, of course. So how to develop the null hypothesis? Let's say a car manufacturing claims that the level of emission from its new engine is lower than its old engine. So we have a case here where we have an old engine and a new engine. We're going to look at particles emitted on the air. And of course, the new has to emit less than the old one. That's why we build a new one. So mu will be the level of nitrous oxide emissions. And then here we have the hypothesis. So you can say, oh, the null is nu equals to the old, and the alternative is nu different than the old, or it's nu equal to the old and nu lower than the old. What do you guys think is the right one? Think. It have to be the lower one, right? Because that's lower than the old engine, right? So this is not good. Cross it in your class notes. This is the one that we want, right? We want to say that is equal to or lower than. So first thing, you have to know how to write the hypothesis. It's not difficult. Think about that logic that I just explained to you guys. Then I'm going to select the confidence interval and the lower level of confidence, right? And the level of confidence is how much I want to be confident with the right answer. And what the 1 minus this is how much I can be wrong, basically, right? So the confidence level will give me my p-value level, which is determined later. Usually we're going to use 95%. And that's basically the relationship between what we call type 1 error and type 2 errors, right? So imagine that again, we're in a jury and we want to put someone, how do you say it? Process someone for their crimes, right? So basically, you have 2 situations that can happen, or 4 situations that can happen, right? You can either convince the person, and the person could be guilty or not guilty. Or you could not convince someone, and they can be guilty or not guilty, right? So you have 4 different situations that can happen. And that's what this one is showing, right? So if if the null hypothesis is true, if the null hypothesis is false. And if you do not reject the null, or you reject. Again, if you remember, you don't accept the null, you can reject the null or not reject the null. And when you reject the null, when you reject that there's nothing going on, you're accepting the alternative hypothesis. So what we're doing is actually rejecting the non-existence, not accepting the existence, right? So that's the tricky part. So when you, let's say you reject the null, right? You say, oh, that's actually, there is a difference between those 2 samples, okay? And that's actually, the null is true. So then you're making a mistake, right? And what is the chance of making that mistake? Well, that is the p-value. The p-value is a type 1 error, is the chance of actually being wrong. Okay, that's why we want to get it very, very small. Okay, so whenever you're rejecting something, it's 1 in 20 is 5% chance of actually that not being the case. The null was right and we rejected. So very small chance, 5%, and there's no math on that 5%. Someone start doing that and everybody just copy and it's going to be there forever. But you can be right? You can reject and it's false. When you don't reject and it's not true, that's okay, right? But when you don't reject and it's false, then it's a type 2 error, right? So the type 2 error, we don't talk to that very much, right? Because again, is the least of the problems, right? So think about, again, putting someone in jail, right, for a crime. You want the chance of that person being guilty and get free, right, higher than you put him in jail and he is actually not guilty, right? Being in jail and being not guilty, that's the worst of all, right? You want to reduce as much as you can that probability. It could happen, but you want to reduce that, right? So it is better to set someone free and say, oh, okay, we were not sure that he was the murderer or not, so we couldn't put him in jail, but he could be the guilty, right? So it's less damage than you put someone in jail that it's innocent. So that's the kind of relationship type 1, type 2 error. I hope that clears stuff.